This is Common Core State Standard Support Video in Mathematics. The standard is 6EEB8. This standard reads, write an inequality of the form x is greater than c or x is less than c to represent a constraint or condition in a real world or mathematical problem. Recognize that inequalities of the form x is greater than c or x is less than c have infinitely many solutions. Represent solutions of such inequalities on number line diagrams. Grade 6 is the first grade level where the term inequality appears in the Common Core State Standards in Math. Standard 6 NSC 7A states interpret statements of inequality as statements about the relative position of two numbers on a number line diagram. There's a standard in the same cluster, 6EEB5, that talks about understanding solving an equation or inequality as a process of answering a question. And that question would be, well, what values from a specific set, if any, make the equation or inequality true? Looking forward to 7th grade, there's standard 7EEB4B that deals with solving word problems leading to inequalities of the form px plus q is greater than r, or px plus q is less than r. And again, this deals with inequalities. Since the idea of inequality is fairly new to students, it might be a good idea to make absolutely sure that students understand what an inequality is. The key knowledge for students is that they realize that there's only three possibilities when comparing two numbers. So these three possibilities would be either the two numbers are equal or they're not equal to each other. And if they're not equal to each other, then a given number is either going to be smaller than the other one or it's going to be bigger than the other one. So there's our three possibilities. If I'm comparing one number to another one, it's either going to be equal to, smaller, or greater than the other one. Also relatively new to students would be this idea that with an inequality, you can have infinitely many solutions. They're used to equations where typically you just have one solution. So let's say we have c is greater than 5. Well, 6 is greater than 5, so is 7, so is 8, so is 9, so is 10, and so forth. So initially, we might be tempted to do this, that our solution set is 6, 7, 8, 9, 10, and so forth. But wait. There's another standard in this same grade level, 6NSC6C, that states find and position integers and other rational numbers on a horizontal or vertical number line diagram. So we're not just dealing with whole numbers here. Well, what about 5.5? That's bigger than 5. What about 7.2? What about 9.671? That's bigger than 5. So now, realizing that, hey, there's these other solutions, I pop them into my solution set. But wait. Well, what about 5 1/5? Or 5 2/3? Or 7.1? Or 7.8? Or 9.675? At this point, it's starting to look like, hey, there's a whole lot of solutions to this. And one thing that should be apparent is that there's no way that you can state all the solutions in set notation. It would be physically impossible to write down every single possible number that's bigger than 5. So here's where this last part of the standard comes into play. This idea of representing solutions of inequalities on number line diagrams. So stating our solution as a set in set notation just won't work in these cases. So we can't do that. We have to go with the number line diagram. So let's say, okay, we have 5, 6, 7, 8, 9, 10, 13, and let's not worry about the 5 for now. But we had all these other numbers like 5.5, 7.2, 9.671, but that's still not enough. We know that all the numbers from 5 to 6 would work, and from 6 to 7, from 7 to 8, and so forth. So it includes all of those numbers. So that's the reason for having the line, because that indicates inclusion of all of those possibilities. Now what we need to do is resolve the issues or the questions at the end of each segment. Well, let's see, our number needs to be bigger than 5. Now that indicates that the 5 is not included. So how do we represent that on a number line? Well, when we have a circle, a little circle with the interior included, that indicates that it includes that number. If it's just the circle, that indicates that that particular number is excluded. It's not part of the solution set. So here we have C is greater than 5, so the 5 is not included, so we have to put an open circle to indicate that 5 is not part of the solution set. Now what about at the other end? What about numbers past 13? Those are bigger than 5. So yes, we have to keep going. And the way that we do that is we simply convert this to a ray to indicate that numbers keep going infinitely in that direction. Number lines can take different appearances. Some might decide that, well, we don't need those dots anymore, so let's get rid of them. And in fact, typically in a number line, you use small hash marks to indicate the location of various numbers on the number line. So this is one possible format or look to the solution set for this number line. But a lot of times this will suffice, because mathematically that's correct. I have all the numbers that are greater than 5, but not including the 5 indicated with this ray. Let's take another example. We have some number D is less than 12. And we're going to do our number line diagram, so we know we have to start at 12. It's less than, so we know it doesn't include it, so it's open circle. And less than, so it should be everything to the left. And of course, this is a habit that students need to get into. They need to test the result with these inequalities. Well, let's see, a 10, that's lies in that part of the number line, and that is less than 12, so it works. So that is the correct solution. Let's try another example. Let's try 9 is less than C. Well, it doesn't include the 9, so it's an open circle. And we have a less than symbol, so I guess it's everything to the left. Wait a minute. Test your result. Well, let's see. Let's try a 7. Wait a minute. 9 is not less than 7. That doesn't work. So that's not correct. The trick here was that the variable was on the right-hand side of the inequality, which throws things off. So let's try the other side. A 10, for example. Hey, 10 works. 9 is less than 10. And 11 works. 9 is less than 11. Oh, so it looks like it's all the numbers this way. So our solution set is all the numbers larger than 9. Again, be very careful, especially in situations like this where the variable in an inequality is to the right of the inequality sign. Well, what about x is greater than or equal to c, or x is less than or equal to c? The symbols greater than or equal to and less than or equal to do not appear anywhere in the standards. But it needs to be addressed because students will see this symbolism, either on a test or textbooks or somewhere. X greater than or equal to c is actually a double statement. It means that x is either bigger than c or it's equal to c. If we use some numbers, let's say we have x is greater than or equal to 4. That means that our unknown is either bigger than 4 or it is exactly 4. If we do this as number line diagrams, one statement says that our number is bigger than 4, and the other statement says or it's equal to 4. It can be one or the other, so it includes numbers in both statements. So we need to put them together, and here's the result. So it'd be everything larger than 4, and it does include the 4 because it can be equal to 4. Okay, we did this example. We have numbers smaller than 5, and we have our number line diagram, and it is an open circle at the 5 because it doesn't include it, then D is less than or equal to 5. Well, the only difference is that it does include the 5. So the difference between the two number line diagrams is simply whether or not the 5 is shaded, because that indicates if it includes it or not.